Hey guys, this is Saurav here and welcome to another session for the KVPY SX program for grade 12th, and this session is on the chemical and physical properties of organic compounds. Organic compounds के ऊपर हमने last session जो किया था उसमें primarily we had taken questions from GOC and isomerism. Today we would continue on that path and we'll take questions on mechanisms. Okay, so I would request you guys to sit with a pen and a paper to solve all the questions simultaneously. We would be taking a few questions which are quite important ones which have come in the previous years, and our endeavor would be to cover all the questions जो कि पहले के A में आए हैं, उसके साथ ही साथ आप बहुत कुछ revision आपका हो जाएगा. Okay, so please do watch the previous video if you haven't. Let's move ahead. ज़्यादा समय waste नहीं करते हैं. So आप दिस इज द सेकेंड सेशन फॉर ऑर्गेनिक केमिस्ट्री. इसके बाद और दो सेशन होने वाले हैं. सो ऑर्गेनिक केमिस्ट्री विल बी डूइंग बहुत आराम से, बहुत अच्छे से करने वाले हैं. ओके, सो लेट्स मूव अहेड. लेट्स टेक द फर्स्ट क्वेश्चन. द फर्स्ट क्वेश्चन इज दिस. द फर्स्ट क्वेश्चन इज फ्रीडल-क्राफ्ट एसाइलेशन इज द फर्स्ट ऑप्शन अल्फा एसाइलेशन ऑफ अ कार्बोनिल कंपाउंड, एसाइलेशन ऑफ फिनॉल्स टू जनरेट एस्टर्स, एसाइलेशन ऑफ एलिफैटिक ओलेफिन्स, acylation of aromatic nucleus. So to solve this question you should be aware of what Friedel-Crafts acylation is. Friedel-Crafts acylation and Friedel-Crafts alkylation are two very important reactions of aromatic nucleus. इस reaction में होता क्या है कि you have an aromatic nucleus. Aromatic nucleus का मतलब एक aromatic ring. It will undergo reaction with a acyl Acylium ion. Acylium ion. Acylium ion is an ion which is generated when this compound is made to react with a Lewis acid like AlCl3. Okay, acylium ion होता है ये. You remove this part. And the ion generated will be like this: CH3C double bond O with a positive charge. This is known as the acylium ion. Acylium ion is obtained from acyl halide. This compound is known as acyl halide, and this acylium ion reacts with the ring and results in the formation of C double bond O CH3. So this is known as acylation reaction. अगर alkylation reaction हो रहा है then we would be taking CH3X, CH3Cl और CH3OH. हम लोग बहुत सारे तरह के कंपाउंड्स ले सकते हैं which can generate carbocation, and carbocations if react with this compound that will be Friedel-Crafts alkylation. So acylation, you have acylium ion plus aromatic ring. Okay, remember this reaction is known as electrophilic aromatic substitution, EAS. electrophilic aromatic substitution बोलते हैं. हमेशा याद रखिए कि इसको ऑप्शन डी के लिए गिना जाएगा. This will be acylation of aromatic nucleus. Remember this. Friedel-Crafts alkylation, Friedel-Crafts acylation आपने 11th स्टैंडर्ड पढ़ा है. इसको एक बार फिर से रिवीजन कर सकते हो just to refresh your memory. Okay, apart from एसाइल हैलाइड, प्लीज डू राइट इन द कमेंट सेक्शन कि एसाइल हैलाइड के अलावा हम और कौन सा कंपाउंड ले सकते हैं फॉर एसाइलेशन. फॉर जनरेटिंग दिस एसाइलियम आयन व्हाट एल्स कैन वी टेक एस अपार्ट फ्रॉम एसाइल हैलाइड. मेरा ये नहीं कहना है कि आप यहां पे ब्रोमीन लगा दिए, आयोडीन लगा दिए, वो नहीं. माय पॉइंट इज ऑल टुगेदर व्हिच अदर फंक्शनल ग्रुप कैन वी टेक so as to generate this ion. Okay, please do write in the comment section. I'll respond to it. Let's move on to the next question. The next question is this: cyclohexene is reacted with bromine in CCl4 in dark. The product of this reaction is a very easy question, very simple one. Now इसको solve करने के लिए आपको थोड़ी सी एक important information जाननी होनी चाहिए that this, let's say, is cyclohexene, and if it is being made to react with bromine in CCl4 present in dark conditions, you would get a, let's say this is the cyclohexane system. ये अगर cyclohexane system है, so it undergoes addition, and इसमें जो addition होता है, the addition takes place by a anti-addition. The meaning of anti-addition is that the two bromine groups would attach from opposite directions. So agar this is the plane of the ring, then one bromine is sitting from the top, one bromine is sitting from bottom. Okay, now when you are doing this, remember, since they are sitting from opposite directions, it is anti-addition. और एंटी एडिशन होगा तो उनके बीच में जो रिलेशनशिप रहेगा, दे विल बी ट्रांस विथ रेस्पेक्ट टू ईच अदर. ओके, सो one bromine will be over here, another bromine will be over here. So how would we identify कि इनमें से product क्या है? Okay, how would we identify? What would not at all be the product is this. ये तो हो नहीं सकता है because you have to add two bromine. ये हो नहीं सकता है. The option that could confuse you is A or B. So to understand what is A or B, we need to know that what does this representation mean. So इस representation का मतलब क्या है? This is the chair form of cyclohexane. So this is the chair form of cyclohexane. Now when you look at the chair form of cyclohexane, if you take these 2 points over here, bonds are present like this. Bonds are present like this. Okay, bonds इस तरह से रहते हैं. दूसरे पॉइंट्स पे भी bonds इस तरह से रहेंगे. Okay, now the point is, you might ask कि सर हम इस तरह से क्यों बना रहे हैं? Why are we not drawing it flat? The reason is, each carbon of cyclohexane is sp3 hybridized. So sp3 hybridization आपको मालूम होगा कि इस तरह का दिखता है, either like this, and if I take the mirror image, it will look something like this. So if you look at each and every carbon, okay, if you look at each and every carbon, doesn't it look like a tetrahedron? अब देखिए, हर कार्बन एक टेट्राहेड्रन के जैसा दिखेगा. So you cannot draw the bonds flat. If you make the bonds flat, it will not look like a tetrahedron. Okay, you take this part, it will look like a tetrahedron. So every point has to look like a tetrahedron. For every point to look like a tetrahedron, I have done this. Clear? Once this is done, what we need to understand is, what does this representation tell us? Okay, तो अगर मुझे ये representation को replicate करना है, if I have to replicate this, if I have to redraw this, what I would do is, I will make this, I will put bromine over here, I will put bromine over here, and this bond is H, this is H. Clear? Understood? Now try and understand कि what is the relation between the outcome of the anti-addition and this. ये जो compound अगर आपने बनाया इस तरह से, if you draw it flat, okay, if you draw it flat, this suppose you are observing, you are an observer over here. You are an observer over here. तो आप ऊपर से अगर इस मॉलिक्यूल को देखोगे, then this hydrogen will appear towards you at this carbon. इस कार्बन पे ये हाइड्रोजन आपको अपनी तरफ दिखेगा, and this bromine will look away from you. Similarly, if you look at this carbon atom, this bromine will appear towards you, and this hydrogen will appear away from you. Try and understand. So if you are looking from the top at this carbon atom, hydrogen is towards you and this is away from you. This bromine is towards you and this hydrogen is away from you. So if I draw this molecule, I have to draw one bromine away, one bromine towards the viewer. Okay, so this is the viewer. Viewer इसको देख रहा है, एक ब्रोमीन अपने तरफ, एक ब्रोमीन अवे दिखेगा. अगर मैंने ये ले लिया, ओके, इफ आई टेक दिस, इसको अगर मैं बनाऊं तो दिस ब्रोमीन, ऊपर से हम देख रहे हैं, दिस ब्रोमीन विल अपीयर टुवर्ड्स द व्यूअर, ऑल्सो दिस विल अपीयर टुवर्ड्स द व्यूअर, बिकॉज यहां पे देख लो, टुवर्ड्स द व्यूअर, टुवर्ड्स द व्यूअर. सो if I draw this in this form, both of them appear towards the viewer. In anti-addition, should one bromine and the other bromine be both of them be towards the viewer, और एक towards होना चाहिए, एक opposite होना चाहिए. क्या होना चाहिए? एक towards, एक opposite. So this will be the right answer. The right answer is A. ये गलत हो जाएगा, ये गलत, ये गलत. It's not a very straightforward question, however, very, very beautiful one. Okay? I hope you have understood this. If you haven't, please do write in the comment section that what you extra input that you need to know about this. Chaliye. Next question is this. Two isomeric compounds 1 and 2 are heated with HBr. The products obtained are what? Clear? So when you react alcohol with HBr, what will happen is OH will get replaced by Br. Okay, so remember that ROH, when it's being made to react with HBr, you will get RBr. ठीक है? But if it is AROH, AR means aromatic. AR means aromatic. If it is AROH और HBr से reaction करते हो तो no reaction होगा. The reason is substitution is not possible at a aromatic carbon or a phenyl carbon. ठीक है, बिकॉज वहां पे एक पार्शियल डबल बॉन्ड कैरेक्टर रहता है, एंड सेकेंडली दैट कार्बन कैन नॉट एक्वायर अ कार्बोकैटायन नेचर. सो नाइदर SN1 nor SN2 reaction can take place. So OH, this OH will remain intact and this OH will remain intact because this OH looks like aromatic connected to OH. Aromatic connected to OH, so no reaction. So हमारा जो ऑप्शन होना चाहिए उसमें ये दोनों OH चेंज नहीं होने चाहिए. We do not have to change this. So this cannot be an answer. This cannot be an answer. This cannot be an answer. The only answer possible is this. Okay. देखो अगर मैं if I go by elimination, A will turn out to be the answer. This is CH2OH. This looks like a alkyl group. And alkyl connected to OH will change into RBr. So conversion तो हो गया, ये नहीं होगा conversion. But यहां पे OH कैसे आया इसको हम बता देते हैं. तो suppose you have AROR reacting with HBr. Doesn't it look like AROR? You will get AROH plus RBr. Okay, AROH plus RBr. Reason क्यों? When the reaction takes place, AROH एक इस तरह का आयन बनता है, and then Br minus attacks over here because substitution cannot take place at the phenyl carbon or the aryl carbon. So you will get this. So हमारे पास क्या होना चाहिए? AROH. ठीक है? Very easy question. If you just know this property, you can solve the question by elimination. Answer हमारा A आ जाएगा. Next question is this. The possible number of enantiomeric pairs produced from the bromination of 1 and 2 respectively. Again bromination के ऊपर question. So bromination is an important reaction. Bromination के ऊपर जितने question आप solve कर सको उतने question solve कर लीजिएगा. This is a very easy question. कैसे हम solve करेंगे इसको? So I have this molecule. ठीक है, हमें bromination करना है. तो इस molecule का अगर मैं bromination करता हूँ, I will be getting something like this. CH3 C Br CH3 C CH3 Br CH3. I would be getting this. Bromination will give this. Clear? यहां पे मुझे क्या मिलेगा? whenever bromination takes place, what you have to do, जो whatever double bond that you're seeing, carbon carbon double bond, वहां पे 2 bromine attach कर देना है आपको. So what you have to do is you will attach 2 bromine atoms at the carbon atoms which share the double bond. So you will get Br CH2 Br. Now tell me something. हमारे पास 2 products आ गए. Okay, when you look at these 2 products, can you identify which of the, so does this molecule have a chiral center? Because enantiomers, to form enantiomers, I need to have optical activity present in the molecule. So first and foremost, do they have a chiral center? So if I look at this carbon atom, these 2 groups are alike. These 2 groups are alike. For a carbon atom to be behaving as a chiral center, all 4 groups should be different. Okay, so no chiral center, so no enantiomers. So for first one it will be 0. First one के लिए 0 हो जाएगा, 0 0. So B is not the answer and D is not the answer. What about the second compound? This is a chiral center. Because if you look at this carbon atom, it is connected to CH3, it is connected to Br, it is connected to CH2Br, it is connected to CH2CH3. Okay, so ये जो group है और ये group, ये दोनों different है. Do not think that कि oh, I have to stop at CH2 because ये CH2 एक जैसे हो गए तो ये chiral नहीं होगा. ऐसा नहीं है. We have to go further ahead and check the whole length, that whether this whole part is the same as this part or not. So these 2 parts are different, these 2 parts are different. So our molecule has 1 chiral center, and if there is 1 chiral center, the number of enantiomeric pairs will be 1. Okay, number हमें pairs identify करना है. This can be R or इसका absolute configuration R हो सकता है, or you can say that its absolute configuration is D, dextrorotatory हो सकता है. Its enantiomer will be levorotatory. That's it. 1 pair of enantiomers. So the right answer should be A. Okay, the right answer will be A. Chalo. Next question. The possible stereoisomers for this molecule are, I don't know whether how many people know this molecule. This molecule is known as an alkylidene cycloalkane. The molecule is known as alkylidene cycloalkane. This is alkylidene and this whole part is cycloalkane. This molecule comes under those class of molecules which do not have a chiral center, but the molecule has overall chirality, just like allenes. इस molecule को अगर मैंने represent करना है, ये molecule की बहुत important feature होती है that this molecule looks like this. So this, you can see this cyclohexane system. So मैं cyclohexane को इस तरह से बनाता हूँ. The cyclohexane is like this. Okay, and this is the double bond. This is your COOH. This is H. And this will be your OH. This will be H. The molecule looks like this. Now, what does this representation mean? If I create 2 planes, one plane contains this, one plane contains this, the other plane is mutually perpendicular to this. the other plane is mutually perpendicular to this, which contains this part. So जो molecule है उसमें this point of contact is the point of contact of two planes which are mutually perpendicular with respect to each other. Now the test for a molecule to be chiral is whether it contains a plane of symmetry or not. So suppose I take this plane, ये plane जिसमें COH and H present है, and इस plane को लेके हम इस molecule को काट देते हैं. Okay, I bisect this molecule, the horizontal plane, by this vertical red plane. So horizontal plane is green, the vertical plane is red. I bisect this. If I bisect this, what will I get? I will get OH on this side, H on that side. It will not be symmetrical. So plane of symmetry is absent. Similarly, if I use the green colored plane to bisect the red colored plane, red colored which is vertical plane, I would get COH on the top and H on the bottom, and they would not be symmetrical with respect to each other. So this molecule will exhibit optical activity. Optically active. If this molecule is optically active, then the possible stereoisomers will be enantiomers. They would not be distereomers or rotamers. No. The right answer should be enantiomers. Clear? So let's move ahead. The major product of the following reaction is, okay, I don't know how many of you know this reaction or not. Can you see this molecule? If you look at this molecule, a molecule किस तरह का दिख रहा है? यहाँ पे दो OH group है. Usually, if a molecule contains one OH group and you put that molecule in H+, it will generate a carbocation. Okay? It will generate a carbocation. So, whenever you have a molecule and you put that thing, molecule containing OH, and you put that thing in H+, it will generate a carbocation. ये एक simple funda है, इसको याद रखिए. It's a rule of thumb. Now, how do we assess कि इससे क्या मिलेगा हमें? So, this is a vicinal diol. This is a vicinal diol. Vicinal means the two adjacent carbons contain OH group. Okay? Whenever you see a vicinal diol and it is being made to react with H+, the reaction is known as pinacolone rearrangement. This is known as pinacolone rearrangement. This question, pinacolone rearrangement, इस बार JEE advanced में भी question आ चुका है. Pinacolone rearrangement is in IIT JEE syllabus, so please do review it. Pinacolone rearrangement में होता क्या है? That if I take a vicinal diol, it will convert into a carbonyl compound. That means aldehyde और ketone में convert हो जाएगा. कैसे होता है reaction? देखते हैं. So if I take this molecule, I put a OH group over here. This is MEOH. Now, the moment I put H+, I will form a carbocation. Lekin the molecule is not symmetrical, so there are two possibilities of formation of carbocation. I can form a carbocation over here, और carbocation मैं यहाँ बना सकता हूँ. तो जहाँ भी OH लगा हुआ है, that will convert into a carbocation. So there are two possibilities. If I write the two possibilities, I would get a carbocation like this. I might get a carbocation like this. मतलब शायद ये मिल जाए, या फिर we might get something like this. So either of these two carbocations can be obtained or can be thought to be obtained. However, the carbocation which is actually obtained experimentally is this carbocation. ये नहीं मिलता है हमें. Okay? ऐसा क्यों? Because this is a more stable carbocation. So the first step of pinacol-pinacolone rearrangement is formation of a stable carbocation. Why is this not stable? Because a 4-membered ring है, 4-membered ring, 3-membered ring, 5-membered ring would not want to have a positive charge on the ring. Okay, they would not want to have a positive charge on the ring. So this is not a stable carbocation, this is a stable carbocation. This is a 3 degree carbocation, काफी stable है. अब क्या होगा इसके आगे? From here onwards, the reaction will take a very simple course. What will happen? This bond will migrate. This bond will migrate, and we will get something like this. You must have read about carbocation ring expansion. So this is ring expansion. ये यहाँ से break करके यहाँ पे चला जा रहा है. That means you break this bond and make a bond from here to here. ठीक है? So एक 5-membered ring बनेगा where you would be having 2 methyl groups on 1 carbon and you will get this. In the last step of the process, you remove a H plus ion. You remove a H plus ion. H plus ion ये वाला remove कर दीजिए. Oxygen and this positive charge will result in the formation of a pi bond and ये बन जाएगा ये compound. So our answer for this question should be C. Answer for this question should be C. So this is known as pinacol-pinacolone rearrangement. If you are having some confusion about pinacol-pinacolone rearrangement, you can go on to the reaction mechanism series that हमने पहले किया था. उसमें मैंने ही पढ़ाया था pinacol-pinacolone rearrangement. एक detailed video है on pinacol-pinacolone rearrangement. Please do watch that to understand how does this reaction take place. Okay? चलिए next question पे चलते हैं. The following reaction is known as, this is phenol reacting with CHCl3 NaOH heat. You are getting a compound like this. This compound is known as salicylaldehyde. The compound is known as salicylaldehyde. Okay, I'll write over here because some part is missing. The compound is known as salicylaldehyde. The reaction in which phenol is made to react with chloroform and NaOH to form salicylaldehyde is known as Reamer-Tiemann reaction. The right answer is C, Reamer-Tiemann reaction. In this reaction, a very important thing that you need to know, that the intermediate is CCl2 dichlorocarbene. Intermediate is dichlorocarbene. So remember, phenol reacting with CHCl3 NaOH is giving salicylaldehyde is Reamer-Tiemann reaction. Now you might ask that Perkin reaction क्या होता है? Perkin reaction is of aromatic aldehydes when they react with acetic anhydride. Perkin reaction, aromatic aldehydes reacting with acetic anhydride or acid anhydride. Sandmeyer reaction is of benzene diazonium salt converting into aryl cyanide or bromide or chloride. Cannizzaro reaction is a disproportionation reaction on or disproportionation reaction of compounds, carbonyl compounds which do not contain alpha carbon hydrogen bonds in presence of concentrated NaOH. Reamer-Tiemann reaction phenol का reaction होता है. ये तीनों में से कोई भी reaction phenol के reaction नहीं है. ये diazonium salt का reaction है. This is benzaldehyde. This is any aldehyde which does not contain any alpha carbon hydrogen bond or any carbonyl compound which does not contain alpha carbon hydrogen bond. Right answer is C. Next question is this. In the following conversion, what are the products respectively? So दो step में reaction दिया गया है. This is aryl cyanide, okay, benzene CN. So ये reaction क्या होगा? पहले हम इसके products लिखते हैं. So इसको products लिखने के लिए let's write it over here. क्या होगा products? सो दिस इज एराइल साइनाइड. अगर आपने फर्स्ट स्टेप का रिएक्शन लिखने की कोशिश की, देन यू विल गेट समथिंग लाइक दिस. दिस इज C ट्रिपल बॉन्ड N and MEMGBr is Grignard reagent. Okay, methyl magnesium bromide is Grignard reagent. So MEMGBr, Me carries a del negative charge. Over here carbon carries del positive charge. So Me will come over here and this bond will open. And you would be getting something like this. C Me double bond N minus MgBr, यहाँ एक प्लस चार्ज रहेगा. When you react this with water, you would get a very unstable compound, not very unstable compound, unstable under the given conditions. You will get a compound like this, NH. This is known as imine. ये वाटर में जैसे ही आता है, the moment it comes in presence of water which contains H plus ion, H2O H plus दिया गया है, H3O plus is nothing but H2O H plus, it will convert into this. कीटोन में कन्वर्ट हो जाएगा. सो CN will convert into Me लगा दो और C डबल बॉन्ड कर दो. सो you will get X will be this compound is X. Now can you identify what is the second reaction? NaOH in presence of I2. NaOH in presence of I2, this is known as haloform reaction. This is known as haloform reaction. In this reaction we prepare haloform, और haloform इस तरह से बनाते हैं. इसको अगर मैंने NaOH plus I2 के साथ reaction कराया, if I perform this reaction with NaOH and I2, then this part, can you see this part? जो ये CH3 part है, this CH3 will change into CHI3 and the rest of the part will change into COONA. It will change into COONA. Na क्यों लिखा? क्योंकि ये बेसिक मीडियम है, तो सोडियम सॉल्ट ऑफ कार्बोक्सिलिक एसिड इज फॉर्म्ड which when treated with H3O plus will form COOH. Always remember, whenever you have a aldehyde or a ketone which has a structure like this, CH3 C double bond O, यहाँ पे आप H हो, or over here there is any alkyl or any aryl. If the structure is like this, if ever the structure is like this and you are making it react with NaOH plus X2 where X is chlorine, bromine, iodine, तो क्या होगा कि this bond will break from here, this part will change into CHX3, the other part which is present over here will change into the carboxylic acid salt. We'll get this. Invariably हमेशा ऐसा होता है. ठीक है, तो यहाँ पे तो हमने क्या लिया है, benzene with COCH3 is known as acetophenone. So acetophenone will generate CHI3 and benzoic acid at the, so this is Y, ये Y है. देख लो कंपाउंड्स, acetophenone, benzoic acid हमारा प्रोडक्ट्स होना चाहिए. Let's look at the options. So हमारे ऑप्शंस क्या हैं? NCH3 नहीं, NH2 नहीं, NCH3 नहीं, CH3 COH, right answer is third, C हो जाएगा ऑप्शन. Okay, major products X and Y will be whatever is given over here in the third option. ठीक है, या फिर C option. Clear? Chalo, let's move on to the next question. The major product of the following reaction, very simple reaction. Can you see this compound? This compound is a vinyl halide. The compound is a vinyl halide. So this is the compound it looks like this: double bond CHBr. Okay, and you are reacting it with NaNH2. NaNH2 is a very strong base. मतलब काफी ज्यादा स्ट्रॉन्ग बेस है, उसको ये फर्क नहीं पड़ता कि H+ कहाँ है. इफ इट इज सीइंग H+ आयन इन इट्स विसिनिटी, वो H+ को रिमूव कर देगा. सो NH2 will remove this H, this bond will come over here, this will go out. 1 2 3, I would be getting HC triple bond CH. Our product should be acetylene. कहाँ पे acetylene है? A. Right answer is A. Clear? This is a question from the topic hydrocarbons, so please do revise hydrocarbons. Next question is this: the major product of the following reaction. देख लीजिए एक बार क्वेश्चन, देख लीजिए अच्छे से. The major product of the following reaction. Okay, so concentrated HBr has been taken, and we have to evaluate that which of these products are correct. एक चीज देखो, हम एलिमिनेशन से इसको सॉल्व करते हैं. लेट्स ट्राई टू सॉल्व दिस बाय एलिमिनेशन. कंसिडर HBr है, सो Br2 तो लगेगा नहीं, इट विल नॉट जनरेट Br2. दिस विल नॉट हैपन. क्लियर? कंसिडर HBr at the max, मैंने क्या बताया था? Whenever OH is treated with H+, carbocation is formed. So concentrated HBr will provide H+ ion. Because this is an acid, it will react with H2O. This will break off. I will get a carbocation. If I get a carbocation over here, then automatically I can say that the anion present in the medium, which is Br- will just get attached over here. Our product should be this. Our product should be this. लेकिन हमारे पास ये ऑप्शन जो दिया गया है, क्या ये सही हो सकता है? No, because Br is being attached over here and the double bond persists. So this will not happen. Okay, this will not happen. The right answer will turn out to be this one. The right answer will turn out to be this one. Clear? So whenever you take an alcohol, when you react with HBr, you will get this compound. However, this is not a very correct answer. This is not a very correct answer, because HBr के साथ alkene भी react कर सकता है. So of the given choices, B turns out to be like okay-ish correct. But इसके बाद भी reaction end नहीं होगी, मतलब इसके बाद भी reaction हो सकती है. So HBr can further react with this and it can generate this compound. So we do not have any option like that. The closest match is B, so we are taking B. ठीक है? इसको हमेशा याद रखो कि HBr के साथ ये reaction, this will be the final product. This will be the intermediate, this will be the final product. Clear? Let's move ahead. The reaction which gives following molecule, can you see this following molecule? This is tertiary butyl methyl ether. This compound is prepared using a reaction known as Williamson ether synthesis. Williamson ether synthesis takes place when I take an alkyl halide and I take a sodium alkoxide. Sodium alkoxide का मतलब sodium salt of an alcohol. Okay, so this is an alkoxide. This is an alkoxide, CH3ONA. It looks like the sodium salt of CH3OH. This is an alkoxide. This is an alkoxide. This is an alkoxide. So we need an alkyl halide and a sodium alkoxide. यहाँ पे देखो alkyl halide. So alkyl halide. Have we taken alkyl halide in reaction C? No. So this reaction cannot occur. Have we taken alkyl halide over here? No. If we have not taken alkyl halide in these two cases, our option would be either of these two. तो रिएक्शन इस तरह से होता है कि RO minus Na plus reacts with R dash X and ये अटैक यहाँ पे करेगा, ये बाहर निकल जाएगा and this will produce ROR dash. This is an ether and the mechanism is SN2. You must have seen that in a SN2 reaction, this species which is providing electrons will behave as the nucleophile, this will behave as the leaving group, and this will behave as the reaction site. Okay, ये substrate जैसा behave करता है. Now, the only limitation of Williamson ether synthesis or for SN2 reaction is that this R group should be 1 degree benzyl or allyl. तो ये जो है R dash conditions are R dash can be methyl, 1 degree benzyl or allyl. Okay, the reason why we have taken these is because if I take R dash as these, SN2 reaction is favorable, but if I take R dash as 3 degree, then elimination ho jayega, because you must have read that substitution competes with elimination and elimination reaction will be favored if this alkyl halide is branched. So अब देख लो इसमें से choices हमको देखना है. So R dash, this alkyl halide वाला जो alkyl group है, that has to be methyl or 1 degree or benzyl or allyl. So in which case it is, this is 3 degree alkyl halide and this is methyl halide. So which is the best choice? B. It does not depend on the size of the nucleophile. Nucleophile के size के ऊपर कोई dependence नहीं है. As long as you fulfill these conditions, you will get an ether. ठीक है? Next question. The major product of this following reaction. Can you see this react compound? देख रहे हो आप? Benzene, alkyl halide, AlCl3. ये कौन सा reaction है? Our first reactions twin brother. This is Friedel-Crafts alkylation. This is Friedel-Crafts alkylation. In Friedel-Crafts alkylation, what happens is formation of carbocation takes place. देखते हैं कैसे होता है. So this is the compound. What will happen if I write the structure of this whole thing? It would be like this: C Me 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 C Me 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 H CH2Cl. Okay, when I react this with AlCl3, I would be getting CMe3 CMe3 H CH2 plus AlCl4 minus. Now, very important property of carbocation is that carbocation undergoes rearrangement. Again, if you want to know how carbocation rearranges, you can watch the reaction mechanism series on the Vedantu channel, Vedantu JEE channel. वहाँ पे एक Wagner-Mervin rearrangement करके एक वीडियो होगा. Wagner-Mervin rearrangement and allylic rearrangement में हमने carbocation के rearrangement को वहाँ पे समझाया है. Okay, so what will happen? This H will go all the way over here. By performing 1,2 hydride shift, we would be getting Me3C Me3 plus CH3, and this reacts with this compound. Reaction predominantly takes place at the para position because alkyl groups are ortho and para directing groups. They will increase the electron density at the ortho position and the para position with respect to them. इनके रेस्पेक्ट में ये ऑर्थो है, ये पैरा है, तो पैरा पे एंड ऑर्थो पे इलेक्ट्रॉन डेंसिटी इंक्रीज करेंगे, बट pushing the group at the ortho position is difficult because the size of the group is large, so steric repulsion हो सकता है. So the product formed over here would be CH2 CH3, and I attach this carbocation over here, Me CMe3 CMe3. Our product should be this. So let's look at the options. Okay, we do not have any option like that. Iska matlab, what was the reason is that CH3 whole thrice CMe Me Me, this carbocation connected to methyl. I think this is actually this there is a misprint in the question. This should had been CH3, just plain CH3 होना चाहिए था, otherwise हमारा आंसर मैच नहीं करेगा. ये चीज जो है ये CH3 होनी चाहिए थी. This should have been CH3 whole twice. If this is CH3 whole twice, then our answer will match. I will get this as the product. A मिल जाएगा. But if I place CCH3, okay, so looks incorrect because 3CH3 तो है नहीं, so it doesn't look right that there should be CCH3 whole twice. That doesn't look very right. It should have been CH3 whole twice. Okay, so let's move ahead. Okay, let's take this question. The final major product obtained in the following reaction is. So simple question hai. NaNH2NH3. Can you see this compound? This is an acetylene. When an acetylene is made to react with NaNH2, the product formed would be, so this is the compound triple bond CH. When this is being made to react with reagent 1, I would be getting C triple bond C minus. Why would this be obtained? क्यों obtain होगा? क्योंकि this is a strong base. It will remove this acidic proton. Okay. This would now be made to react with CH3I. अब देख लो ये alkyl halide है. This is nucleophile. So this will perform a substitution reaction. I would be getting C triple bond C CH3. I would be getting this. Now this is hydrogenation with in presence of palladium. Hydrogenation in presence of palladium. This will perform complete hydrogenation. तो यहाँ पे CH2 CH2 CH3 हो जाएगा. The right answer should be D. ठीक है? The right answer D हो जाएगा. Next, R2-bromobutane upon treatment with aqueous NaOH will give. So 2-bromobutane can undergo SN1 reaction, can undergo SN2 reaction. What reaction will take place? Let's see. So R2-bromobutane, if it undergoes SN1 reaction, then we would be getting a mixture of enantiomers. Okay, we would be getting a racemic mixture. In fact, racemic mixture. और अगर ये SN2 reaction होता है, then it will give us S2-bromobutane. Inversion हो जाएगा. Now the point is which reaction will take place over here. This is a homework for you guys. Please revise SN1 SN2 reactions to tell me what is the answer to this question in the comment section. How did you arrive at that answer? आप बस ये मत लिख देना कि भाई A हो जाएगा आंसर या B हो जाएगा आंसर. ये बताओ कि आपने अगर A बोला आंसर, then what is the reason for saying A? If B is the answer, then what is the reason for saying B? We will take this question in the next session, and this is the last question for today. So please do like, share and subscribe the video so that it reaches to all the masses, so that उनकी KVPY की प्रिपरेशन भी अच्छी से हो जाए. And we'll start from this question. So please do join us the next week for another exciting KVPY session. Please do revise a bit of organic chemistry क्योंकि हमारे पास variety of topics से questions आते हैं. Okay? So अभी तक हमने बहुत I don't think हमने 2012 क्रॉस भी किया है. ओके हमने 2012 तक के ही क्वेश्चंस लिए हैं, तो 2013, 14, 15, 16, 17, 18 अभी बाकी है. सो try to like revise a bit of organic chemistry and come prepared for the next session. So this is Saurav Goswami taking leave, and I wish you guys a very, very lovely day ahead. Bye bye guys, and have a lovely day.